Press the bell icon on the YouTube app and never miss another update.
Good morning, friends. So last time we had a discussion on VSEPR theory, and we discussed about the shapes and geometries of different molecules. So today we will be starting a discussion on the concept of dipole moment, represented by mu, and SI units are d by. What does exactly happen in the shapes of the molecules, and how can we find out the dipole moment of the molecule? We may have individual dipoles of the atoms which are, or of the molecules which are polyatomic, but we can have the net dipole moment of the molecule to be zero. First of all, let me just explain what this dipole moment exactly is. You see, whenever you take any covalently bonded molecule like HCl or NH3 or water, wherein between two atoms there is difference in electronegativity. So looking on the difference in electronegativity, we know chlorine is more electronegative than hydrogen. So chlorine will pull electrons away from hydrogen. As a result of that, hydrogen gets a positive charge, but that is not a 1+ charge that is obtained during the ionic bond formation. This is the moment of electron from hydrogen towards chlorine due to more electronegativity of chlorine. But keep it in mind, although chlorine being more electronegative than hydrogen, but the size of chlorine will be a bit bigger than that of hydrogen. So it's not able to expel complete electrons away from hydrogen unless and until this HCl is interacting with the base. Because when this acid interacts with the base, the lone pair of electron in a base will be attacking this H+ ion, which is delta plus charged. And once lone pair is donated, it will make a bond with that base, thus chlorine leaving becomes easier. So if there is no base present, HCl molecule will not be able to depart out and break out very easily. As a result, because electrons don't move completely towards chlorine, you are getting delta plus charge, and equal amount of delta minus charge is obtained on chlorine. Clear or not? Dipole moment, it's a vector quantity. What it means? It is direction dependent, and the moment of electron is because it is from electropositive to electronegative element. Chlorine being more electronegative than hydrogen, thus the direction of dipole is from positive to negative. In physical terms, what does dipole moment mean? Now you see, children, there's a difference of charges between two atoms, correct? Now when you represent it as dipole moment mu, it's equal to the charge on either of the atoms into the distance of separation between the two. Now arbitrary, when you look on mu, which is equal to Q into R, as I mentioned, its value is d by, and 1 d by equals to 3.35 into 10 to the power minus 30 coulomb meters. Now how exactly? Because Q in charge in terms of coulombs and distance in terms of meters, it may be given in picometers, it may be given in angstroms, and conversion is required for that purpose. Now when you look on this case, children, if you see any molecule and if there is a complete change from of the electrons from the electropositive element towards electronegative element, we will have one plus full charge and one minus full charge. Now in this case, we consider that this bond which has come into play has become 100% ionic. Now technically this bond is covalent, but it has got what character in it? Ionic character. So if you want to calculate percentage ionic character in a covalent bond, percentage ionic character in a covalent bond, last time we discussed it, percentage ionic character in a covalent bond. So we are finding out ionic character in which bond? Covalent bond. Last time in our discussion, what did we find out? We found out percentage covalent character in ionic bond. Here we are finding out what? Percentage which character? What bond? Covalent bond. What character we are finding in it? Ionic character. What was about earlier? Ionic bond. What character we were finding? Covalent character. So percentage ionic character is mu experimental divided by mu theoretical into 100. Let me explain this, what it means. Now, when I say mu experimental, it means the dipole moment you have just calculated on the basis of the values given, that is Q and R values given to you. Now, mu theoretical is the dipole moment which you consider to be coming into play in the molecule when there is complete moment of charge from hydrogen to chlorine. Hydrogen becoming plus, complete plus, 1 plus, and chlorine becoming 1 minus. So at that time, the dipole moment you will calculate will be mu theoretical, and for different molecules it's different. Arbitrary, the maximum value that you have for it, mu theoretical, is 4.8 dB. Keep it in mind, when it is 1 full plus charge, keep it in mind. So the value of that 1 full plus charge will always remain constant. The only thing that will keep on changing will be R, correct or not? Once R keeps on changing, what will happen? Dipole moment will keep on increasing. Did you get the point clear here? Now, physical terms, what does dipole moment mean? In physical terms, dipole moment means when any polar molecule is put in the electric field, how does the molecule move in presence of the external field and align itself with the given field? So the moment of a dipole within the electric field in physical terms is called as dipole moment. Mathematically, dipole moment equals to Q into R, and as I said, the value is 1 d by SI unit is d by, and it's 3.35 in 10 to the power minus 30 coulomb meters. Clear, children? Now, as we understood here, when we are looking on a dipole, it is moving away from hydrogen and moving towards chlorine. Technically, I would say the electron density is moving away from a positively charged region towards negatively charged region. So the direction of dipole is from positive to negative. Clear or not? Right. Now, looking on this dipole analysis, and when you look on different molecules, you will find out, so in different molecules, when there is electronegativity difference between the atoms, you will have a definite dipole coming to play. But what is the net dipole of the molecule? That needs to be seen. Whether you may have the individual bonds in a molecule with some polarity, but it's not always true that the net dipole moment of molecule will also exist itself, because we need to see what is the shape of the molecule and what's the geometry of the molecule respectively. So our next discussion will be dipole moment and VSEPR theory, because shapes in the last class we have already understood very well. Now on the basis of those shapes, we will take certain molecules into consideration and try to explain their dipole moments, whether dipole moments will be existing or not at all. Clear or not? So let us see on these discussions, children, one by one. So did you get the concept of dipole moment clear? Yes, there is one more way in which you can calculate percentage ionic character. And what is that? So if we have not been given the value of Q and R, but what has been given is the electronegativity of atom A and electronegativity of atom B. So if these two atoms are given with their electronegativities, is there any chance to find out percentage ionic character in that covalent bond? Absolutely, yes. So that percentage ionic character in the covalent bond where electronegativity of the two atoms is given will be equal to what? It will be equal to 16 into electronegativity of A minus electronegativity of B plus 3.5 into electronegativity of A minus electronegativity of B whole square. When do we use this? These equations can only be used in a molecule when you have been given the electronegativity differences between the two atoms. If you have been given the dipole moments, then it's very easy to calculate out the ionic character of the molecule respectively. So keep it in mind, when I'm talking about mu theoretical, it means 100% which character? Ionic character. And in this case, you will have a complete plus charge and you will have a complete minus charge coming into play. Right. So let us see certain examples and find out the dipole moment of different molecules using VSEPR theory into play here. Right? Yes. So take your notes out and see exactly how the molecule will behave. I will use the same protocol what we have used in the last discussion. Exactly. So let us see certain discussions over here in a proper fashion. First of all, let us take a molecule of AB2 type. So technically this is a triatomic molecule. Clear? AB2 type molecule, whether dipole moment will exist or not, we need to see that. First, AB2 type molecule, let us say beryllium chloride, BeCl2, correct? Already we know what's the hybridization of this molecule, sp. What's the geometry? Because there is no lone pair on beryllium. What's the shape? It's linear. What's the geometry? It's linear. So looking on beryllium, this will be the chlorine and this will be chlorine, correct or not? Now beryllium and chlorine, which is more electronegative? Chlorine. So electron density will move towards chlorine. Here electron density will move towards chlorine. Because the vectors are going in opposite direction, they will cancel down and the net dipole moment of the molecule existing will be 0. This is what type of molecule? AB2. I have not taken any lone pair into consideration here. Clear, children? Clear or not? Let us look on one more molecule which is of also AB2 type, but it's an ion now. Say we have a molecule of NO2. What's a molecule? NO2, but the charge is plus. Correct? Now let's have a look. 1/2 of V plus M minus C plus A. We all know it. In our last classes we have done it. 1/2 of. What's the number of valence electrons for nitrogen? 5. But it has lost 1 electron. So total 4. Clear or not? Any monovalent atom? No. Any cation? Any cation? Yes, that I have already subtracted. So if you want, write it more clearly. Valence electrons 5. No monovalent atom. There is a charge of cation that needs to be subtracted. No anion. So 5 minus 1 will be 4. By 2 will be 2. So hybridization is what? sp. Correct. sp hybridization. That means NO, because it has a divalent atom. So we'll got nitrogen, double bonded to oxygen, double bonded to oxygen. Now remember one thing. When you look in a dipole, a double bond is considered to be one entity. Clear? Oxygen being more electronegative than nitrogen, net dipole is towards oxygen, So NO2 molecules dipole also will not be existing at all. But yes, this is ion, net dipole is not existing. This is ion and it is charge is existing due to the presence of what? Due to loss of electron from NO2 respectively. Is it clear? This is NO2 plus. Now if you look on NO3 minus, which one? NO3 minus. Look on the case, NO3 minus. Now we know what's a hybridization. sp2 obviously. Want to calculate it? Nitrogen, how many valence electrons? 5. Gained 1, 6. Bond is made, 6. Remaining electrons, 0. Because it's a divalent atom. Correct or not? Because it has divalent atom, so minus 3 pi bonds. So total how many sigma bonds? 3 sigma. So what's a hybridization? Obviously sp2. Now according to this, is there any lone pair? No. What should be the shape of the molecule? Obviously has to be triangular, planar. Correct? So let's draw it. Nitrogen. We can have a double bond with oxygen. We can have one oxygen with a negative charge. And we can have one coordinate bond with one more oxygen. Clear? Dipole moment upwards. Yes. Here. Yes. Towards oxygen. Correct. Resultant will be downwards. 2 will cancel. Net dipole moment will be 0. Polar or non-polar? Obviously non-polar. What about BeCl2? Non-polar. What about NO2? It has positive charge, so it's an ion. But net polarity of the molecule, which I calculate on the basis of the direction of the dipole, is also 0. Hope I'm clear with this point here. Yes. Look on one more molecule. We'll go further forward because you know hybridization concepts already. I'm using the dipole interactions to calculate things very easily here. Right, children? Yes. Let us see one more molecule. We move a bit forward. We move to tetra-atomic molecules. Which one? Say CH4. All of us know it's a non-polar molecule. Why? Why? Because tetrahedral, almost there is no difference in electronegativity between the atoms, so it will be non-polar. Instead of that, if I take Cl4, what's a hybridization? sp3. Should be no doubt in this. So when I draw it, carbon, you got chlorine, then you got one wedge, and you got one dash coming into play. Clear? What is this one? Chlorine. This is chlorine. Tetrahedral or not? So when you see the tetrahedral molecule, all the dipole moments, when you take, they are going towards chlorine, but the net dipole moments with opposite directions in tetrahedral moment, and the net dipole moment of the molecule will be 0. Let us change one chlorine here. And instead of that, what we make now, it is as CHCl3. So how many chlorines are there? 3. So naturally, I will draw a general shape. Carbon, we got chlorine, and we got which one? Hydrogen. Now 2 chlorines will cancel in dipole, right? Now, chlorine being more electronegative than carbon, yes. charge on carbon, and the bond between carbon and hydrogen will be almost non-polar, I would say. So this molecule will have some net dipole moment. So net dipole moment will not be zero. There will be some apparent charge on the molecule present respectively. Is it clear? So this will be polar or non-polar? Obviously polar. What about CH2Cl2? Polar or non-polar? Some polarity will exist or not? Yes, because two hydrogens cannot cancel the effect of two chlorines respectively, right? So it also will be a polar molecule for us. Yes or no? Let us make some typical examples into consideration which involve lone pair of electrons as well. Keep it in mind, children. Dipole moment affects the physical and chemical property of the molecules as well. Keep it in mind. Because dipole moment existence in a molecule will mean its interaction with the charges will be either more or not there, right? And we already know in organic chemistry, in a simple terms, the charge dispersal leads to the development of nucleophiles and electrophiles, which become electron-rich centers during the attacks respectively. Fine. Okay, children. Now, let us look on some typical examples. I'll take 3-4 examples into consideration so to understand it very clearly. First of all, let me take a diatomic molecule with a lone pair of electrons into consideration as well. Clear? So first of all, I will draw water molecule. All of you will be knowing the basic dipoles for this. Now, in water molecule, we have a tetrahedral geometry. Correct, children? I'll draw that. We got oxygen and we have two lone pair of electrons. This is one and this is the second one. You got two lone pair of electrons. Then you got hydrogen and you got one more hydrogen. Because we have learnt in VSEPR theory that we do not need to show the shapes. Clear or not? We already learnt it out in VSEPR theory. Now, children, looking on these two, oxygen is more electronegative than hydrogen, so definite dipole will be existing. And dipole direction will be towards what? Oxygen. So oxygen will be having delta minus charge on it from the hydrogen. This will be delta plus and this will be delta plus. Correct or not? So the direction of dipole will be towards oxygen from positive to negative. Correct? So here also the direction of dipole will be towards oxygen. Correct or not? Yes or no? Yes. The resultant of the two will be in the direction of oxygen. This is one. So there is some net dipole existing towards oxygen itself. Now have a look on the lone pair of electrons. Now, do lone pair of electrons exert any dipole moment or not? Yes. Oxygen will be considered as the region of positive charge for the lone pair of electron. Because when the lone pair of electron will move away from the nucleus of oxygen, what it will do is, it will generate this region as a positive center. Correct or not? And this region where towards which electron flow is moving in the orbital, which is technically sp3 orbital. So electron density will be increasing, so making this region as a negative charge, right? So there will be a dipole for a lone pair also, and there will be one more dipole for one more lone pair also. So the net dipole of the two will be upwards. So both of these are going in same direction or opposite direction? Same direction. So what is the vector rule? Vector rule is when the two vectors going in the same direction, they will be added or subtracted. They will be added up. So the resultant dipole of water molecule is very high. These hydrogens will become what? Positive regions, and the oxygen will become what region? Negative region. Keep it in mind. Dielectric property of water can also be explained on the basis of this concept. I don't want to go into the details of that here. Is it clear, children? Yes. What's a hybridization? sp3. What type of molecule? AB2. With how many lone pairs? 2 lone pair of electrons. Clear? Clear or not? Yes. One more example. Let us take now BF3. Then we are taking NH3. And then we are taking NF3. All these are triatomic. But I have told you already in hybridization concept that having molecular formula to be same, like AB2, AB3 type, doesn't comply that hybridization will be same. Not having the same molecular formula also does not give us the information that hybridization cannot be same, right? What's a basic rule we need to look? We need to look into lone pair of electrons and bond pair of electrons respectively. Very good, children. BF3, basic rule, we will do it. How many valence electrons are there? 3. How many fluorines are coming? 3. What's a hybridization? We already know. sp2, no need to discuss it out, already done in our basic classes previously. Yes, correct. sp2 hybridization, no lone pair of electron involved, because boron, how many valence electrons? 3. How many bonds made? 3. Any remaining electron? 0. All of these are what bonds? Sigma bonds, right? So for sp2 hybridization with no lone pair of electron, what's the geometry? Or even if there is lone pair of electron, what's the general geometry? Trigonal planar or triangular planar, correct? So we got boron. Yes, there is fluorine, and there is one more fluorine, and there is one more fluorine. Correct or not, children? Have a look now. What will happen? So the dipole will move towards fluorine, here towards fluorine, here towards fluorine, because fluorine is more electronegative than boron. Resultant dipole downwards or not? The two will cancel or not? So the net dipole moment of the molecule will be 0. That's definitely non-polar. Clear? Look on NH3 molecule. I'll use the rule. Nitrogen. How many valence electrons? 5. How many bonds made? 3. How many remaining electrons? 2. That means 1 lone pair. Correct or not? You got 1 lone pair or not? Yes. 3 bonds. 1 lone pair including. Hybridization will be sp3. So what's a basic geometry? Tetrahedral. Let us draw that. So nitrogen. One position of tetrahedral geometry is taken by lone pair. Then 1 by hydrogen. 1 more by hydrogen. 1 more by hydrogen. Keep it in mind. These are in triangular pyramidal position. And if you want to pass through it, there's a hole moving through it. So it will be like this. You have nitrogen here. You got 1 bond here. You got 1 bond here. And you got 1 bond here. So it's like a tripod stand. Is it clear or not? And on the top of it, there is sitting what? Lone pair of electron. Yes, I proved a while earlier. What is the direction of dipole for a lone pair of electron? Away from the atom holding it, right? So this one will be the direction of dipole. Correct or not? Upwards. Yes or no? Right. Nitrogen and hydrogen. Let me just remove this off because I just showed it for the purpose of shape a while earlier. Hydrogen and nitrogen, which is more electronegative? Nitrogen, electron density moves towards nitrogen. This one also towards nitrogen. This one also towards nitrogen. So resultant in which direction? Upwards. Here also upwards. So the net dipole moment will be upwards only. Now the question is, in water molecule also there is synergistic effect. In NH3 also there is synergistic effect. Why then the boiling point of water is higher than that of ammonia? Answer is very simple. The difference in electronegativity and the presence of lone pair of electrons. Basic thing, difference in electronegativity. Oxygen being more electronegative than hydrogen, this develops more positive charge on hydrogen compared to this hydrogen respectively, correct? So hydrogen bonding tendency is stronger when the partial positive charge developed on the proton by the electronegative atom is more. We know it already. What is that? Yes, FH hydrogen bond is stronger than OH hydrogen bond, which is stronger than what? Nitrogen, hydrogen bond. Remember, hydrogen bond is shown by 3 dotted lines. There's a difference between half bond and hydrogen bond. When you show half bond means partial bond, then you show many dotted lines. But when you show hydrogen bond, you show only 3 dotted lines respectively. Clear, children? So resultant dipole in which direction? Upward. So is it polar or non-polar? Definitely polar. What's the next one I have taken? Look here. NF3. Have a look. NH3, NF3. If you look on the molecules, you assume, sir, we assume the dipole moment of the two should be almost equal. But remember, the dipole moment of NF3 is less than the dipole moment of NH3. Let me explain that anomaly here. Yes, children? NF3, obviously hybridization will be again sp3. Yes or no? Let us see what happens. Nitrogen, 1 lone pair of electrons. Then you got fluorine. Then you got fluorine. Then you got fluorine. Again, children, shape is triangular pyramidal. I can draw that out, right? So tell me now here. Here the dipole was moving towards the atom holding the lone pair, right? Here in same direction or opposite direction? Same direction or opposite direction? Obviously opposite direction because fluorine is more electronegative. So it will move here. This will move here. This will move here. So the net dipole is coming down or going up? Coming down. It is dipole will go up or come down? Go up. So dipole moments are going in opposite direction. What will happen by that? Because fluorine is more electronegative, so there will be definitely some dipole moment towards the direction of fluorines only. But because there is cancellation, that's why in ammonia there is synergism. In case of NF3 there is antagonism. They are moving in opposite direction. So vectors going in opposite direction will cancel the effect, but complete cancellation will not come into play because fluorine will execute or exert more dipole moment compared to that of lone pair of electron. So there definitely will be some dipole moment existing due to what? NF3 respectively. there will be some dipole moment due to NH3, but the dipole moment of NH3 will be more than NF3 respectively. Am I clear here? Clear or not? Yes. One more thing. You can look on beryllium chloride and water, BeCl2 and water molecule easily. Beryllium chloride, sp hybridization, water, sp3. Which of the two has higher dipole moment? Water. That's why you can see that bent shape of water is responsible for its different properties because there will be net dipole moment existing. But in BeCl2 or BeF2 molecule, you will have no net dipole moment existing respectively. Am I clear with the thought, children? Yes or no? Clear? Move a bit further forward, children, into some typical examples further. Let us take two more examples to just give you the brief spectrum of this concept as well. What about the dipole moment of PCl5 molecules, children? Yes. What about the dipole moment of SF4? Let us take those examples one by one. I will take PCl5. All of you know. 5 bonds means 5 valence electrons. 5 bonds made. 0 remaining electrons. Hybridization sp3d. Now tell me. In my last classes I told you, if you have watched those well, that when there is sp3d hybridization, where should you put the lone pair? In the plane, out of the plane? Yes. Out of plane. That means at what position? Axial position. But we do not have any lone pair of electron here at all. So what is the basic shape of the molecule that we have to draw? Geometry and shape will be same here. Yes. So we got what? This is one bond. This is second. And this is third. So these are 3 chlorines. Then you got one above the plane and one below the plane. Now you can see that very easily. So this is a triangular position, triangular planar. And if you connect this, it becomes bipyramidal. What is here atom we have? We got chlorine, we got chlorine. Opposite direction or same, they are in axial positions, right or not? Opposite directions of cancellation will occur or not? Now, it is dipole moment will be this direction, correct? This is also chlorine. This is also chlorine. This is also chlorine. Because you have an angle here. So when you do the physical terms of, or the basic mathematical terms of vector addition, the resultant dipole will be here or not? Correct or not? Towards chlorines. So they are going in same or opposite direction. Opposite direction, cancellation will definitely occur. Net dipole moment of PCl5 molecule will be 0. What's the hybridization? sp3d. One more important thing. Let us look on the molecule of SF4 now. Which molecule is it? SF4. Clear or not? Now, in SF4 molecule, sulfur valence electron 6, bonds made 4, remaining electrons 1 lone pair. That means 2 electrons. Clear? Now, 4 bonds already made. By 1 lone pair, it can make 1 more sigma bond. So what should be the hybridization? It should be sp3. Any doubt here? sp3d to be precise. Clear? What should be the basic geometry? As I told you last time, according to hybridization, draw the geometrical consideration, draw the geometrical arrangement. Geometrical arrangement will be, there is 1 lone pair and 4 bonds. Whenever there is lone pair in sp3d hybridization, according to mathematical calculation that I gave last time, you should give lone pair in the plane or out of plane. Out of plane, let me do that. So I will give 1 bond above the plane. Which one? Lone pair or not? Yes, I will draw that. So this is lone pair. I have given it above the plane. Should I give above the plane or in the plane? In sp3d hybridization. I should give it in axial or equatorial position. Quick. Above the plane or in the plane? In the plane. Yes. So I will give a lone pair of electron in the plane. Yes, I'll do that. So this is 1 lone pair of electron in the plane. Then there is 1 bond in the plane. Then there is 1 more bond in the plane. Triangle complete or not? Yes. Now 1 above the plane, 1 below the plane. Clear or not? What is this one? Lone pair of electron. It is dipole is upwards, right? Alright. If I connect it this will be a triangle. And above it, below it, pyramidal. Triangular pi pyramidal. So what is the direction of dipole of a lone pair of electron? Away. Which atom is it? By the way, sulfur. This is fluorine. This is fluorine. This is lone pair. Again here, fluorine. This is fluorine. Dipole moment downwards. Dipole moment upwards. The 2 will cancel down. No dipole from these fluorines. At what position? Axial positions. Clear? Now these 2 fluorines will have a direction of dipole in the middle of the 2, right? And lone pair is going opposite direction, this direction. Will they cancel? No. Fluorine being more electronegative will exert more effect compared to that of lone pair of electron. As a result of that, this molecule on the whole will have some dipole moment. So dipole moment will not be 0. This molecule will be polar. although there is cancellation of some polarity, but there is no complete cancellation of the polarity coming to play at all. Thus, this molecule will be polar. One more molecule we can have a look. Say children, BrF3. I'm just taking these examples into consideration. BrF3. Yes. Bromine, how many valence electrons? Oh, it's halogen, right? 7. How many bonds made? 3. Remaining electrons? 4. That means 2 lone pairs. How many bond pairs? 3. Total 5. Hybridization will be sp3d. Now, this is important. How many lone pairs you got? 2. Where should you give lone pair? In the plane, out of plane? Obviously, in the plane. So, how many lone pairs I have to give now? 2. I will do that. Now, I am giving lone pairs. 1 here, correct or not? And 1 here. So, I have given 2 lone pairs. Right, children? And then, 1 bond I have to give in the plane. Which one is it? Fluorine. Above it, fluorine. Below it, fluorine. Have a look. 1, 2, 3. Triangle completed or not? Oh, yes or no? With lone pairs, basic geometry is triangular bipyramidal. But at the end, we don't show lone pair of electrons. The shape will be T shape. Correct? So, these fluorines will cancel down or not? Net dipole moment due to fluorines at what position? Axial position will be 0. Now, fluorines and 2 lone pair of electrons, will cancellation occur? Definitely not. So, now dipole moment due to this will not be 0. So, on the whole, it will be polar. Clear? What about XeF2? XeF2, xenon, valence electrons 8, bonds made 2. I hope you are understanding what I am doing, because last time I have done it profusely what exactly I am doing. How many electrons remaining? 6. That means 3 lone pairs. How many bond pairs? 2. Total 5. So hybridization sp3d. How many lone pairs are there? 3. Now whenever you have 3 lone pairs, where should you give those? Equatorial or axial position? Equatorial. Give that. So 1, 2, 3. Done. So triangle completed, children. Yes. 1 above the plane, 1 below the plane. Which one is it? Fluorine. This one. Cancellation will occur or not? And dipole moment of 2 lone pairs will also cancel. Net dipole moment of 2 lone pairs will be this direction, and there is 1 individual lone pair of electron. The cancellation will occur. What will be net dipole moment of the molecule on the whole? 0. Am I clear? This molecule is which one? XeF2. Let us change it a bit. Let us change it a bit, children. Let us make it XeF4. Xenon, how many valence electrons? 8. Bond is made. 4. Remaining electrons. 4. That means how many bond pairs? 4. Hybridization. sp3d2. Clear? For sp3d2 hybridization, children, what is the shape we have? What's the geometry we have? Square planar bipyramidal. I am going to do that. And I have how many lone pairs? 2. And where should I give lone pair of electrons in sp3d2 hybridization? Last time we discussed, what was it? In the plane, out of plane. It should be given at what position? Out of plane. That means at what position? Axial position. So how many lone pairs I have here? 2. So I will give 1 above the plane, 1 below the plane. Done or not? So these are 2 lone pairs. Then how many bonds I have to give in the plane? 4. 1, 2, 3, 4. What is this? Fluorine. 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 Now tell me, this lone pair is, this is square planar bipyramidal geometry, but the shape will be square planar because lone pairs are not considered, right? So net dipole of lone pair upwards, this will be downwards. Cancels or not? Dear resultant this way, dear resultant this way. Net dipole moment of this molecule will also be 0. Clear, children? So in the same way, when you look on different molecules and try to find out the dipole moments of the molecules, except the mathematical calculation that I have given you, you need to look on VSEPR theory for your answer. So I have proved it that you can have a polyatomic molecule with the individual dipoles existing, but net dipole moment of the molecule will be 0. And you can have the same type of molecular formula like isomorphs. Isomorphs in the way AB2 type molecules. One may have the dipole moment, one may not have. Or both may have the dipole moment, in which one will have less and one will have more. Clear or not? So this explains the concept of what? Percentage ionic character in which bond? Covalent bond. This is also called as polar covalent bond. And last time in my 4 previous classes, what did I discuss? We have some covalent character in which bond? Ionic bond. And for that, what I discussed? Fajans rules. So children, in our next discussion, we will start a further discussion on molecular orbital theory, and we will do the concept of resonance. Before that, we'll do the resonance. After that, we'll go into molecular orbital theory. Thank you. Have a good day.